question 1.2. This has to do with logarithms. Again, it says without a calculator, so we should be able to do it without a calculator. It shouldn't be difficult. All you need to remember is what your laws of logarithms are. Okay, so to do this one, you can see my bases are all different. This is 2, this is 3, this is 5. I can't really do anything. And even if the bases here were the same, because I'm multiplying instead of adding, we don't have any laws that pertain to multiplication of logarithms. So when you have something like this, try and change them to a common base. And the easiest one to do is 10. You can use ln if you want to. There's nothing wrong with that. You can use base 2 if you want to. Your answer will be exactly the same in the end. So I choose to use 10 because that is the common logarithm, and we work with that a lot. So I change this one to 10, so it'll be log 5 over log 2. So I don't write the 10 because we said when the base is 10, there's no need to write it. And then I multiply log 8 over log 3. There I've changed the base, and then I change the base for the next one. This is log 3 over log 5. I hope you remember how to change the bases. We say you write the new bases there, log 1 in the numerator, 1 in the denominator, and then this argument goes over there, and then the base goes in the denominator. That's how you change the base of a logarithm. Okay, so here I have fractions that are multiplying, and then we can always cancel out any terms that appear in the numerator and in the denominator. Like over here, I see log 3 is in the denominator, and here it's in the numerator. It should cancel with that one. What else can we cancel? I see log 5 over here, and log 5, it's in the numerator here and it's in the denominator there. I can cancel, and I only do this because it's multiplication. If I was adding, I could not do that. It must cancel with everything in the numerator. But with multiplication, if it appears in the numerator and in the denominator, I can cancel it. And it doesn't matter which numerator or denominator, just because I am multiplying. Okay, so those two cancel. And I see, what am I left with? I'm left with log 8. Here when they cancel, remember they cancel to give me 1 and not 0. So it's 1 times log 8 times 1, which is just log 8. The denominator, I have log 2 times 1 times 1. This is just log 2. Okay, now this 8 over here, I can rewrite it as 2 to the power of 3. So let me do that. This is log 2 to the power of 3 over log 2. Now remember, laws of exponents. If your argument has an exponent, you can always bring the exponent down, and this is 3 log 2 over log 2. Okay, and here again, same thing I was doing over there, cancelling. I see log 2 in the numerator, I see it in the denominator, it cancels to give me 1. So I have 3 times 1, which is just 3. And just like that, I'm done, and I did it without a calculator. But we can always check, see if what we did is correct. So here I have one of these fancy calculators that can do logs in different bases. So let's try it. So here is log base 2 of 5. If I multiply this by log of 8 base 3, oh sorry, what did I do? Let me start again. This is log 2 5, then multiply log 3, 8 goes there, and then multiply log 5 and then 3 there, and then equal to, you can see the answer is 3, which is what I did over there. Okay,